Well, it's time for section 6.1, everybody's favorite, fractions. So to begin with, suppose that you start with a square. And then take that square and divide it into two equal pieces. So I'm just going to divide it right down the middle here. So that means that this is one out of the two equal pieces, and this is also one out of the two equal pieces. So when you write the number 1/2, then that could be interpreted as one of two equal pieces. So another idea would be, suppose that we have a pizza right here, and there's two kids that are going to share the pizza. So they divide it right down the middle. One kid gets to eat this half of the pizza, the other kid gets to eat this half of the pizza. And by the way, this line right here that I just drew right down the middle, that's called the diameter. So we can work a little bit of geometry in with our fractions. Now suppose that you start with, it could be a square or a rectangle. I'm just going to expand it out, make it a rectangle this time. And then divide it into three equal pieces. So 1, 2, 3. So then this is one out of the three equal pieces. This is also one out of the three equal pieces. And this is one out of the three equal pieces. And then we could do fancy things like, well, what if you shade in two of those pieces? Well, then that red part is 2 out of the three equal pieces, otherwise known as 2/3. Just a quick note, when you write fractions, it's best to write it with a horizontal line like this. So this is better than if you write it like this. Because when you write it like this, although technically it is the same, in quite a few places and people actually do this, but later on when you get more complicated fractions, so right now we're doing like first grade, second grade, when you're doing fourth and fifth grade and you have something like 2 divided by 3 plus 7, then this can be a little bit vague because I'm not quite sure if that means 2 divided by 3 plus 7, or does it mean 2 divided by 3 and plus a 7? So these two mean completely different things. So when you write it with a horizontal fraction bar, it's clearer. Now, for the next example, represent three-fifths with a picture. So we could do it much like this. Start with a rectangle. And then, so this fraction bar also means divide. So divide it into 5 equal pieces. So the number on the bottom tells you how many pieces you're supposed to have. 5 equal pieces. Let me make sure I did it right. 1, 2, 3, 4, 5 equal pieces. And then 3 of those would be shaded. And so that represents 3/5. The red part right there. Well, somebody else might be a little more creative and they do this. So they might say, so this is a picture of my mom. And then got to label it because my picture is not really clear that that's the mom, but that's the mom. And she is 5 feet tall. And then this is a picture of my little sister. And she's 3 feet tall. So this is a different way to represent that information. And this is really proportions. 3 compared to 5. So obviously this person is shorter. They're actually 3/5 as tall as the mom. Okay, then on to the next idea, and that is equivalent fractions. So equivalent means basically equal, but to be more precise and correct, to say equivalent instead of equal, the reason for that is, for example, if you go to the store and you get a dozen eggs for $2, well then your $2 is equivalent to a dozen eggs. But the $2 does not equal a dozen eggs because dollars don't eat eggs. So it's sort of a technicality. If you want to say equal fractions, that's fine. So here's an example. So you take a pizza, but this time the pizza is going to be shared by 4 kids. So we need to divide it into 4 equal pieces. And then how much do 2 of those kids eat? So one kid would eat this piece of pizza. A second one would eat this piece of pizza. So they eat 2 out of the 4 pieces of pizza. Well, at the table next to them, there's also a pizza. And because they're bigger kids, they divide it in half. And one of them eats all of this. So that means that this person just ate half a pizza. And if you compare the red part to the red part, they're actually the same size. And so these 2 fractions are equivalent, or you could just say equal. So that's one way to look at equivalent fractions. Another way is by reducing fractions. So in general, the rule is if you have A times a number over B times the same number, then that can be reduced as just A over B. So for example, reduce the fractions, or it might even say simplify. And for part A, it's going to be, how about 8 over 10? So I'm going to do it using this rule, which means the top has been factored and the bottom has been factored. So on the top, I could factor that as 4 times 2. On the bottom, I could factor that as 5 times 2. And then basically what this rule is saying, the n's cancel each other out. So n divides into n, they cancel each other out. Or here, 2 divides into 2, so they cancel. Or a slightly different way to look at it is 2 divides into 2 one time. So that means on the top, there's a 4 times 1. And on the bottom, there's a 5. And then we're actually done. The only numbers that will divide into a 4 would be a 2 and a 2. But a 2 will not divide into 5. So this one is finished. Then for part B, how about 16 over 24? So I could do the same thing, factor it, and then have the 2's cancel. A slightly different way to look at it is, this is an even number, and this is an even number. So that means they can both be divided by 2. So as long as you multiply the top by the same number, or divide the top and the bottom by the same number, then you're allowed to do that. So on the top, it's going to be 16 divided by 2 is 8. 24 divided by 2 is 12. And then with this one, you could do the same thing, divide by 2 and divide by 2, again over here. Or to speed things up, you could realize each of these could be divided by 4. So divide by 4 and divide by 4. And then on the top, 8 divided by 4 is 2. And on the bottom, 12 divided by 4 is 3. And that can't be reduced anymore, so this one is finished. And just one more. How about if it's 80 divided by 100? So you could do the same, divide by 2 and divide by 2, because these are even numbers. Or, since this ends in a 0 and ends in a 0, you could divide by 10 and divide by 10. And when you divide by 10, that actually just gets rid of those two zeros at the end of each number. And so it would then have an 8 on top and a 10 on bottom. And then divide by 2, since both of those are even numbers. On the top it's going to be 4, on the bottom is 5, and just like that one, can't be simplified anymore, so that one's finished. Then on to the next idea. How do you know that two fractions are equal? So in here, this one is equal to that one. But if you're just given two fractions, how can you determine if they're equal? So that uses something that we use a lot throughout math, which is called cross multiplication. So that goes like this. If you have A over B equals C over D, then you can multiply on this diagonal A times D, and you can multiply on this diagonal B times C, and those two sides have to be equal. So for example, true or false? Are these fractions equivalent? So for part A, how about 3/16? Does that equal 4/12? So you could cross multiply, and the order doesn't matter. I could go ahead and do this diagonal first. So that would be 16 times 4. And then this diagonal, 3 times 12. On this side, that's going to be 64, and 3 times 12 is 36, and that is false. Okay, let's just try one more. How about 9/25? Does that equal 7/8? So cross multiply, multiplying these two, 9 times 8. And then multiplying these two, 7 times 25. So let's see, I know 9 times 8, that's 72. And with 7 times 25, so 7 times 5 is 35. And then this would be 14, 15, 16, 17. That's a 175. Does it equal a 72? Definitely false. Another idea with fractions is every fraction has an infinite number of equivalent fractions. Okay, so pick any fraction. I'll just start simple, like with 1/2. And then what I could do is I could multiply on the top and the bottom by the same number. So multiply by 2. So that would be 2 over 4. And then instead of multiplying by 2, I can multiply by 3 on the top and the bottom. So if you go back to the original 1/2 and you multiply by 3 on the top, it's going to be 3. And if you multiply by 3 on the bottom, it's going to be 6. And then hopefully you could ask the class, do you see a pattern? On the top, the numbers are 1, 2, 3. What do you think's next? And everybody says 4. And what will come after that? 5, etc. And on the bottom, what's the pattern? 2, 4, 6. These are even numbers, so next is 8, 10, etc. So this would produce an infinite list of fractions, and they're all equivalent. All right, with all the fractions we've had so far, the number on top has been smaller, the number on the bottom is bigger. Well, that doesn't have to be. So if the number on the top is bigger than on the bottom, those are called improper fractions. Personally, I don't really like to use the word improper because it's not like they did something wrong. But here's an example, 12 over 5. So that's when the numerator is bigger than the denominator. So the number on top is the numerator, and the number on the bottom is the denominator. So one way to look at that is, this is saying that if you go back to the beginning, our rectangle's been divided into fifths, but how did we get 12 of them? So we've got one rectangle, and it's been divided into 5 equal parts. 1, 2, 3, 4, 5. Then there must have been another rectangle, and it was divided into equal parts, 5 equal parts. And then there was even another rectangle, which was divided into 5 equal parts. And then this part is saying that 12 of those little rectangles have been shaded in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's a visual representation of 12 fifths. Or if you look at that, this is one whole rectangle plus another whole rectangle plus this is 2 fifths. So this is really saying 1 plus 1 plus 2 fifths. Or in other words, it's 2 plus 2 fifths. And then that is also written as 2 and 2 fifths. So the word and replaces this plus, and then this is read as 2 and 2 fifths. So that's one way to take an improper fraction and change it to what's called a mixed number. So it's mixed because it's a mixture of a whole number and a fraction. So the other way to find the mixed number for this improper fraction is to use long division, because this this fraction symbol right here also means divide. So it's saying take 12, divide by 5. So, or another way to do it is take a 5, divide it into 12, and then that will go 2 times. And then 2 times 5 is 10. And now subtract, and the remainder is 2. So in 3rd grade, they would do this. And then, oops, I wrote down a 3 when I said a 2. Sorry about that. And then this can be written as a mixed number. So first of all, it divided in 2 full times. So that would be the whole number 2. and then the remainder goes on top, and the divisor goes on bottom. Okay, so let's just do one more example of that, and then on to the last idea of the section. Almost done, 6.1. So one other example, write 37/6 as a mixed number. So you could draw the rectangles and do it that way, or you could use the division algorithm. So 6 divides into 37. So that'll go 6 times, and then 6 times 6 is 36. And then when you subtract, the remainder is 1. So that means it divided in 6 whole times. And then when you make the fraction, the remainder goes on top. So the remainder goes on top, and the divisor goes on the bottom. So it's 6 and 1/6. Okay, for the last idea, it's inequalities. And the rule basically goes like this. If you have one fraction which is smaller than another fraction, so then that means, so again we're going to use cross multiplying, but we're going to do this one first. So this diagonal goes first. That means A times D is smaller than, and then this diagonal, B times C. And again, the example is going to be true or false, vrai or faux. How about 12/7? Is it smaller than 15/4? So multiply this diagonal first. So 12 times 4, is that smaller than? And then multiply this diagonal, 7 times 15. So on the left side, it's a 48. And 7 times 15, I think it's 105, but I better check. So 7 times 5 is 35. 7 times 1 is 7. 8, 9, 10. Yes, it's 105. So is 48 smaller than 105? That is true. So that means that the original inequality, this is also true. And then just one more. How about 11/2? Is that smaller than 88 divided by 9? So multiply this diagonal first. That'll be 9 times an 11. Is that smaller than this diagonal, 2 times 88? So multiplying by 11, that's pretty easy. It's just going to be 99. This, I think I need to work that out. Times 2. So 2 times 8 is 16. 2 times 8 is still 16. One more is 17. So is 99 smaller than 176? Yes, it is. So this one is true. All right, so that's the homework, or excuse me, that's the lecture for section 6.1, and the homework is 1 through 19, the odds in section B.